Hi, my name is Joseph Cooney, and this is a talk that this is a rough cut of a talk that Leon Bambrick and I are going to be giving at DDD Brisbane 2017. It's called Evergreen Skills for Software Developers. In the presentation, when we actually give it, Leon and I are going to be sort of alternating between these bits, but I'm just doing a whip through sort of everything, see how it sort of hangs together. So I think hopefully as developers, I'm sure I'm not the only one who's had this experience. I think we all sort of know what doesn't really feel evergreen about software development at the moment. There's a bunch of things that where the pace of change just feels like it's accelerating. I think there's a lot of cool things that people want to learn, but it's hard to know where to put your attention. It's hard to know. It's hard to keep up with some fields. You sort of if you sort of try to go deep on one thing and take your eye off something else, you come back to it and it feels like there's often been quite a lot of changes, and so this can feel a little bit daunting for people, including for myself. And in this is just one example from the front end web framework area, where web frameworks like front end development frameworks, JavaScript frameworks, and sort of build tools and things like that. These are all the logos from a bunch of tools, and I mean, just looking at all of those does feel a little bit daunting if each of those is something that you have to learn and understand. These images themselves are taken from an article called "How It Feels to Learn JavaScript in 2016," which is sort of a bit of a tour where a fictitious developer wants to learn how, or what, has been out of the front end game for a little while and comes back and is trying to implement some basic stuff, just showing some data from a database on a page. And the person's friend, who is versed in all of the current modern front end technologies, leads him through this path, this very winding path of sort of tools that he will have to master, or she will have to master, in order to implement what seems like a fairly simple feature. So this feeling brings back to me a quote from Alice in Wonderland, and a paradox called the Red Queen paradox. And so Alice and the Red Queen are having a running race, and they're both running as fast as they can, and they're both staying in the same spot. And the Queen says, "Now you see, it takes all the running you can do to keep in the same place. If you want to get somewhere else, you must run at least twice as fast as that." And so that's a little bit what software development feels like sometimes. In order to just stay where you are, you have to run as fast as you possibly can. And it's no wonder that feels tiring. I guess it's safe enough to say that the pace of change can be a little bit exhausting, and even when you know like where something is going, just the amount of change along a given path can be quite daunting and overwhelming. When you add that to the fact that you're not really sure, I don't think anyone is really sure, where it's all going to end up. That can further add to it, because sometimes you might spend a bunch of time, like I did, looking at certain technologies, and then they die. I mean, they're not gone, but they're certainly not at the forefront of what people are doing. So I was a WPF MVP for several years, and I spent a lot of time learning WPF. I found it quite interesting, and for a while there I was really bought into it being a really good framework to use, but eventually Microsoft sort of de-emphasized it and started putting their interest into other things, which is fair enough. They've got to suit the majority of developers. They can't be sort of. It felt like they had sort of committed to it being the premier framework for doing Windows development going forward, but their priorities changed, and that turned out to not be the case. So that felt bad. I'd spent a bunch of time learning a technology that was sort of, I mean, it's still around, and it's still, there are still projects using it, but it's certainly not at the forefront of development like I felt like it once was going to be. And so even when you know where or you think you know where the industry is going, and even if you're on the path that's kind of winning, the pace of change can be quite daunting. And then if you end up going down a path that ends up being a bit of a dead end, that can be even worse. I did take some consolation from the fact that not everyone gets it right. So here's a Stephen A. Ballmer former Microsoft CEO, sharing some of his views on the iPhone. We don't really know what he was thinking privately, but he certainly came out fairly strongly saying that he didn't think the iPhone was going to be a big deal. And certainly he should have known better, given the amount of research and things like that he could have brought to bear to find out how it was going. Also, this chap here, Charles Petzold, he's sort of an example, or a bit of a cautionary tale as well. He spent a very long time building up a lot of expertise and being sort of a preeminent expert in Win32 API programming. And you can see here he's gone and got himself a Windows 95 tattoo. When it seemed like Windows API programming in sort of C++ and C wasn't really where the future was, Charles decided to make a bit of a pivot, and he pivoted into WPF development as well. And so even though his expertise in Win32 had lasted him probably a good 15 to 20 years, his pivot into WPF didn't really have very much longevity either. And Charles is an expert and was an expert in the industry, and so I guess we can all take comfort from the fact that not everyone gets it right all the time. But it doesn't have to be like this. The flip side of all this, the positive way of looking at all this is that if we're able to kind of sort out these problems and invest our time wisely in technologies that were at the forefront of learning and had a viable future, and also were able to develop skills that had a long lifetime and things like that, we'd be able to be confident in our skills, we'd be able to be always employable, we'd be a valued member of the teams that we were on, we'd be able to open up ourselves to a lot of opportunities. I think if you're at the forefront of something, you often get you can help people, you sort of put in contact with people that can offer interesting things your way. And if you're the one that's kind of on the front foot in your workplace, you'll be the one that they ask to do. Hey, we're looking to put together a new cool HoloLens application, or we're looking to put together a cool new sort of mobile device. If you're kind of seen as the person who sort of gets things quickly and is up to speed with lots of things, you'll be the person that maybe gets those opportunities, and that can create a great positive spiral for you. So that's sort of where we'd like to be, rather than feeling like that we're always on the back foot, we're always just running as fast as we can to stay where we are. So this chap here is Benjamin Franklin, and he was always one to have a bit of a pithy quote. He said, "An investment in knowledge always pays the best interest." And he must have known something about interest and money and things like that, because the Americans ended up putting him on their $100 bill. But unfortunately, not all investments are quite the same. So there are some investments that hold their value very well. For instance, gold. I think gold's made when sort of neutron stars crash into each other, and it's been around for quite a while. And within the human sort of timeline, gold has always been sort of valued and has always been a symbol of wealth, and it sort of continues to hold its value today, even though perhaps logically it shouldn't, but it does. And so there are things that, like gold, that just seem to hold their value for a really long time, regardless of you can pass them on to your children and your grandchildren, things like that. They're just around forever. There are other sort of assets, for instance, like a big pile of bananas that they might be worth. You could go out today, you could get $1 million, you could sell your house, and you could buy $1 million worth of bananas, and those bananas would, at that point in time, they would be worth $1 million. But in a couple of days' time, they're going to be worth considerably less, unless you've managed to sort of sell them off or put them in storage or something like that. And say if you left them just sort of without doing anything special, if you just left them as is, a couple of weeks later, you would certainly not have something worth $1 million. So bananas are what's called a depreciating asset, and so they don't sort of hold their value that well. You might get lucky. There might be a cyclone up in Cairns, and your bananas might be suddenly worth a lot of money. but chances are their value, they will not hold their value for a very long period of time like gold does. So I guess the big idea of our talk is that you should be treating your knowledge investments a bit like financial investments. People have put a lot of time into thinking about how money should be invested, and when you're learning something, you're really investing your time and your reputation and your skills into learning it. And so you can maybe gain some benefits by using some of the principles that people have thought about when investing money in investing in skills. So one of the main ideas with investing money is that you should try to have a mixed portfolio. So you have some low risk investments and some high risk and potentially high return investments. I mean, if you had perfect clarity about what the future was going to hold, you could just put all of your money or all of your time, if you're investing in sort of learning, you could put all of your time into learning the most profitable thing and just doubling down on that and learning it as much as possible. But that would hold a big risk, because that thing might not end up, if you didn't have perfect clarity, if your crystal ball was a little bit cloudy, and as they say, I think in the financial industry, if you use crystal balls, you end up eating a lot of glass. If you do that, and it doesn't pan out, you end up having an investment that that investment could be worth nothing. And so knowledge investments aren't exactly, the analogy between financial investments and knowledge investments isn't a perfect one, but it's certainly worth thinking about diversifying and mixing the portfolio of things that you invest in, and looking at things with different risk profiles. We'll talk later about identifying how risky technology learning opportunities are, and thinking about them. That's going to be kind of like the meat of the rest of this talk. So I guess the ideal would be to invest in skills that aged, that were going to be useful forever. And for a couple of reasons, we're going to see that that's not always possible in the technology arena, but there are some skills that do age particularly well. So the way I like to think of it is sort of like a pyramid, like a food pyramid. At the bottom of the pyramid, we have these sort of metacognitive skills. So these are skills that are about learning and thinking themselves. So things like attention management, learning how to learn, having a sort of the right mindset to allow yourself to learn and grow. These are sort of involve thinking about thinking itself. And so these skills are quite, are very long-lived. A little bit further up the pyramid, we have what I'm calling sort of non-technical skills. I guess another way to describe this, people might call them soft skills, although they're not any easier to practice. They're just not as concrete, or as there's often sort of not quite a right or wrong answer to some of the questions or some of the things that you need to know. It's more of just shades of grey, things on a continuum, stuff like that. So these are things like communication, critical thinking, prioritization, time management, these kind of things. So it's hard to imagine any of these skills ever completely going away. They might change a little bit, but as long as humans are sort of interacting with each other, these are going to be important skills. And as long as people are, having to work in sort of like a business context, these are going to be important. So unfortunately, you couldn't really be a technology professional and just be learning these two things. You'd be sort of more of like a life coach or something like that. In order to be a sort of a technology worker, you need some actual sort of technical skills. I guess project managers kind of would sort of be maxing out on this stuff, but I think most of the people here would be looking to add a bit of a technology bend to their skill set. And so the next level up in the pyramid is what I'm calling implementation agnostic technical skills. So these are sort of the type of skills that are involved in sort of coding and implementing things, but they're not actually tied to any one particular technology. So it's things like design, debugging and troubleshooting skills, like knowing how to decompose things and sort of designing subsystems and stuff like that. Also visual design skills like typography, design patterns, architecture, all that kind of stuff. So they're not tied to any one particular implementation. They sort of translate reasonably well between different technologies, but they're not by themselves, they're not enough to actually sort of be doing and, you know, creating an actual an actual thing that runs. It's sort of more about the skills that you need to get to that point. And finally, at the very top of the pyramid, we have the sort of implementation specific skills, so sort of languages, tools, frameworks, and libraries, that kind of thing. And I think a lot of the talks at DDD will be sort of in this realm here. And when we think about technical learning and sort of professional development, this is where we usually think of, you know, putting our time investments. So here's our pyramid here, and basically we've sort of characterized this, Leon and I, as the bottom two skills are pretty much evergreen. Like, as long as humans are around, these skills are going to be pretty much relevant. The ones a little higher up, the general technical ones, are you know, fairly long-lived, and then the ones at the top of the pyramid tend to be a little bit shorter-lived. And as I've alluded to already, the skills at the bottom are certainly valuable, but by themselves, they're not really enough to be sort of a technology professional. You need some of the things in that general technical and then specific technical skills as well. So I guess when we're looking at creating a balanced portfolio, taking skills from the bottom part of the pyramid, that's like really easy, low risk things to invest in, because we know that these are going to pay off over a long period of time, and not just pay off in your technical career as well. They're going to pay off really well in your everyday life. Being able to communicate with people is valuable, no matter, you know, whether it's at work or at home, in your family, all that kind of stuff. And also metacognitive skills, valuable no matter what you're doing. But like I said, not enough by itself to be a technical person. So before we go, later on in the talk, we're going to look more in detail in the sort of technical skills at the top of the pyramid, and then trying to tease out what are the characteristics that determine sort of risk there. And we're definitely not saying risk is bad. We're just saying you need to be conscious of how much risk you're taking on when you're investing in certain things, and sort of going about it with your eyes open. But in the meantime, we're going to then just quickly touch on some skills from the bottom part of the pyramid that are very low risk. And so these are kind of like the government bonds of sort of knowledge investments, because they just pay a very consistent, easily quantifiable return. So attention management, basically there's sort of a war currently underway for your attention, and the psychology, human psychology has been kind of weaponized against us all. People like Facebook and Twitter, all the social media platforms, YouTube, all those kind of people, they're just using human psychology against us to try and get us to spend more and more time on their sites and their products. Games, you know, the gamification of applications and games themselves, you know, do things to try and build sort of ongoing engagement with their users. And so these things can be great fun if you're just looking to have a bit of fun, but if it's not the way that you want to choose to spend your time, then it can be a big time drain. And so there's a bunch of little just tips here that we suggest that you could adopt in order to sort of gain some of your time back, in terms of attention management. So there's ad blockers. You can use headphones so that you can filter out noise in your workplace, and sort of use there's sort of special soundtracks and things like that to help you focus. You can taking breaks is recommended so that you can sort of go in and out of that focus state more easily, giving yourself a little, you can't just stay focused for like hours and hours at a time. You sort of have to cycle through periods of lack of attention, and so taking specific breaks, going for walks and things like that is really good. And having the strength to kind of delete the addictive apps, turning off autoplay, signing yourself out of social media things, turning off notifications is all very good. There's a book called Deep Work by a guy called Cal Newport, where he makes a very strong case for work that involves sort of deep engagement is going to be really the only thing of value in the information economy. And so people who can perform deep work and can turn off the distractions will be extremely valuable. And so I think we all see in our day-to-day lives, I think we can all probably recognize the problems that all of these platforms and social media things pose, and the productivity problems that they can cause. So certainly mastering that is an excellent an excellent skill to try and build up. Another thing that is worth being aware of is this concept of the two different sort of mindsets. So this is another metacognitive skill that's worth spending a bit of time learning and observing. So there's people aren't typically either, there's sort of two extremes here. One is the growth mindset and one is the fixed mindset. People aren't typically one or the other. It's a bit of a continuum, but the fixed mindset basically says that the way things are is the way that they're always going to be. I'm either good or bad at things intrinsically. There's no amount of effort or anything that I can do to change that. I'm just not good at certain things. And the opposite of the fixed mindset is the growth mindset, where it's just like, if I spend some time on something, I'm going to get better at it. And I think a lot of us, this certainly seems more logical to me because, practicing at certain things just inevitably makes you better at them. There are some things like, no matter how much practice Leon puts in at basketball, he's never going to be 7 feet tall. So there are certain limits physically imposed on us by various things. But I think the number of things that don't yield to some amount of concerted practice is pretty small. And so the growth mindset really encourages us to look at opportunities to grow and things like that. And so I think we need the metacognitive skill of understanding these two mindsets and being able to recognize when we're falling back into the fixed mindset and just saying, oh, I'm just not good at visual design, or oh, I'm just not very good at multi-threaded programming or whatever. These are opportunities for us to then say, well, no, what could I do to get better at them? How could I improve at this? And so, I think understanding those two mindsets is a good metacognitive skill to build up, and once again, something that's going to pay a lot of dividends over time. So this is a low risk investment as well. So we've talked a bit about these, the skills at the bottom of the pyramid and how they pay good returns over time because they are pretty much evergreen. We've also said that you can't be a technology professional just with those bottom of the pyramid skills. You need something from that apex and those skills in this sort of general technical area as well. And so now we're going to look at how to choose those sort of implementation specific skills and general technical skills. Two different ways you can look at technology adoption can sort of help you to understand how risky adopting a technology or choosing a technology to learn is going to be. One of them is the technology adoption lifecycle curve, which is the one on the left, and it's taken from the book called Crossing the Chasm, and the other one is called the Gartner Hype Cycle. So these two things, you can kind of like overlay these in your mind as sort of both happening concurrently when a technology is being adopted. So if we look at the technology adoption lifecycle, we can see that there's it's a bell curve, but unlike a normal bell curve, there's this bit labeled red there called the chasm. Basically, a lot of technologies ramp up and they go through the innovator sort of leading quartile there, and then they get the early adopters, but they never really make the jump over the chasm into being sort of major use and sort of general usage. And so I'm sure there's a lot of technology examples that you can think of in your own life where you've sort of seen something, you think it's really going to be good and up and coming, but it just never really quite makes it. It doesn't cross the chasm. So we can use this chasm sort of and bell curve way of thinking about technology adoption to sort of identify when something's risky and when it's not risky. So we can sort of have a look and see a lot of the technologies that we're sort of thinking of maybe learning are probably in that innovator, early adopter part of the bell curve. And then, so they're inherently more risky because there's a chance that they will fall into the chasm and never come out. There's this early majority, and like I said, risk is not a bad thing. By taking on more risk, you're hopefully exposing yourself to more potential reward as well. You know, if that technology does cross the chasm and you've been on board from a very early time, you're an expert then in a technology that everyone wants to use and is adopting. And so that's a great thing. and you will hopefully gain, respect and notoriety and, like great job prospects from having that skill. But there is a risk that it will fall into the chasm. So definitely not saying that risk is bad. It's just good to understand what you're signing up for. So there are skills, there are technologies that have probably just crossed the chasm or are in this early maturity phase now. Say, for instance, things like Docker, things that have been kind of bubbling away for a while and have kind of now just sort of eventually feel like they've started to hit their straps and have actually made it into the mainstream. So those are maybe things that we can look at and say, well, this thing is definitely not going away now. It's the real deal. There's enough people out there actually using it that it's not just all hype and talk, and it now represents a good thing to invest in learning because it's now a lot lower risk, but I'm still going to be getting a substantial amount of benefit by being able to sort of look at this, to use it during this sort of whole period of its adoption. So we've been talking about the adoption life cycle. Now we'll talk about the Gartner hype cycle, which is kind of similar in a way. So technologies go through this peak of inflated expectations, and then quite often they crash down into what's called the trough of disillusionment. And I guess when we sort of overlay that over the Gartner hype cycle, maybe that's where things fall into the chasm and never quite make it out. And then if they do make it out, they come back through this trough of disillusionment up to the slope of enlightenment, and then eventually the plateau of productivity. And so this is when the technology is sort of been fully adopted and has adherence, and it's just being used and it's part of our everyday now. So I guess that once again, thinking if a technology is becoming really hyped, we can think that, well, there may well be a crash coming up and it may well not make it out of that crash. And so we can sort of say, well, this may be a bit riskier now. If something has had a bit of a crash and then seems to be ramping up after that, you could start to think, well, maybe this thing, it's got enough longevity that it will actually be useful to learn. And so, I mean, obviously this is a very simplified model. This is not all technologies don't follow this path. This is just a way to think about how technology adoption happens. It's not like science or anything like that. It's more of just a way of thinking about it. But you can look at the different. You can look at a technology and say, well, has it gone through these stages where do I think this technology is in this in the hype cycle, and then think about, well, what is the risk profile of that technology? So a good example of a technology that didn't really cross the chasm, but did have a lot of inflated expectations, is, say, Google Glass. One interesting thing about technologies that fail to cross the chasm is that often, or get really heavily hyped, is often that they, even if the particular incarnation of the technology doesn't make it across, there might be enough. If you look a bit deeper at the underlying sort of drivers that led to that technology in the first place, maybe it's like the next iteration or the iteration after that that is going to make it across. So for instance, even though Google Glass didn't really make it, augmented reality as a thing probably is going to make it. I mean, we've got HoloLens, we've got a bunch of augmented reality things in a lot of mobile platforms. So it's hard to imagine that augmented reality as a thing isn't going to make it. So even though Google Glass didn't make it, augmented reality may well do it. So if you're looking at a technology and it ends up falling into the chasm, there are things that you can do to kind of salvage some of the knowledge that you had, some of the more sort of general principles that you probably learned when adopting that technology will probably be able to be used even if the technology itself didn't make it. So if you look at the underlying forces that led to that technology in the first place, even if that particular iteration doesn't make it, the overall thing may well be going to succeed. Longevity is not the only consideration when looking at technical things that you're thinking about learning. There's also just how much fun they are. There's also the demand, even though you might think, well, I think this technology really only has a lifetime of probably only a couple of years. There may be massive demand for it in a short period of time. And so you might think, well, look, even though I know it's not going to be around forever, I'm still going to take the time to learn it just to meet that demand while it's around. And it also might be really useful, even though you recognize it's not going to be around forever. It's like, I'm going to be using this thing day in, day out for the next 6 months. So even though I know that the window of use is fairly narrow, the amount of overall use the amount of times I'm going to be touching this is high enough that it's worth me learning. And so Leon has a bit of a tool that he has developed, basically similar to the sort of Cartesian coordinate magic quadrant Gartner thing. And so you can sort of add a technology. So in this example here, he's added JSON here in the middle as sort of a reference point. And along this axis here, along the horizontal axis, he's using that as the sort of expected duration of that technology being around. And so he's added some other technologies here. So for instance, regex he thinks will be around is going to be around longer than JSON is, and Bayesian mathematics definitely around longer than regex and JSON. C# he thinks is going to be around longer than JSON was, but not as long as regex. And so you can see technologies down here that he said he's basically thought they are going to be less long-lived than JSON. And then on the vertical axis, he's got just the amount of day-to-day use that something gets. So for example, C#, if you're a C# developer, you're probably going to be coding C# pretty often, and so it's a little bit higher up than regex because you might only touch regex occasionally. And obviously this tool is a very personal thing, because it's not only how long-lived you think something's going to be, which is the horizontal, but also how much you personally believe you will use it too. So someone who is maybe a database guy would put SQL much higher up, and maybe someone who's, say, a C# coder, she might put C# much higher up. So this is going to be very personal depending on what sort of stuff you're doing in your day-to-day and where you see yourself going. But you can use this to say, well, stuff that's up here in this quadrant, whatever that looks like for me, is stuff that's really worth learning, because A, it's going to be really long-lived, and B, I'm going to be using it all the time. So I guess Vim, it's hard to adopt, but once you do adopt it, you use it all the time. And so if it's worth learning, the fact that it's going to be probably very long-lived and also used all the time, maybe there's a good case for learning Vim, even though we kind of hate ourselves for saying it out loud. And you get to feel smug and better about yourself than other people. So, there's that too. So when we're looking at long-lived implementation-specific technical skills, so sort of languages and libraries and frameworks and things like that, things in that top part of the pyramid, there's a couple of kind of rules of thumb that we can use, or heuristics that we can use, to think about how long they're probably going to be around for. So we saw on that graph before that we were basically putting certain things on a timeline and saying how long we thought they were going to be around for. And Leon has put regex and SQL and Vim and C# quite high up here. I mean, if I was putting the Linux kernel on here somewhere, I would imagine it would be kind of up here too. And chances are a new JavaScript library that's just been released, we don't really know where to put that on this time frame, but maybe we can use these heuristics to sort of figure it out. So the Lindy effect is a sort of observation that was made about the entertainment industry back in, I think it was like the 50s or the 60s. And it was basically that sort of for non-perishable things like technologies and institutions and cultural things like movies and books and stuff like that, their sort of expected time they'll be around in the future is proportional to how old they are now. So if something's been around for a really long time, it's more likely to be around for a really long time again. So something like the Iliad or the Odyssey, which are thousands of years old, are probably going to be around for thousands of years more. Conversely, something that's a bestseller today, there's a chance that it will be around in 1,000 years, but there's also a chance that it will be gone in the next year or so and largely forgotten. And I think the chances of it being gone and forgotten are much larger than the chances of it being around for 1,000 years. If it manages to stay around for 10 years, or 20 years or 30 years, say like Harry Potter, there's an excellent chance that it'll be around for another 20 or 30 years. But, we've got to assume that that we're sort of encountering things at around the middle of their lifetime. So this is what the Copernicus method basically says. It's that we're not privileged in the way that we observe things in the universe. We're not privileged. The Earth isn't the center of the universe. This was Copernicus's sort of revolutionary claim that got him sort of branded a heretic and all that sort of thing. We're not special. We're just observing things, we're just an unprivileged observer in the universe. And so we can use the Copernicus method to estimate the age of things by saying that we're probably encountering things around the middle of their life. So something like TCP/IP or HTTP, which has been around for, like a couple of decades. Chances are it's going to be around for a couple more decades at least. Something like the new JavaScript library that just came out a week ago, chances are it's going to be gone in a couple more weeks as well. That's the kind of assumptions that we've got to make. And so we can use this sort of information to extrapolate how long we think technologies will be around for. And so technologies that have been around for a while, there are obviously examples where a technology that's been around for a while goes away, but a lot of the technologies that are around now that have been around for a long time will continue to be around for a long time. There's also a bit of a different cadence to different aspects of development. So different technologies seem to sort of follow a bit of a different arc depending on sort of what they are and where they are. So things like tools and libraries, they tend to have a fairly short or shorter cadence. So they're sort of in the order of like months to years. Application architecture tends to be sort of more like half decade. So, we had n-tier architecture, then we had service-oriented architecture, and now we've got microservices. Who knows what the next turn of the wheel will bring there. Frameworks, probably around the sort of half-decade mark as well. Like the ASP.NET Web Forms, ASP.NET MVC, WPF, Silverlight, WinForms, Ruby on Rails, Elixir, all those frameworks sort of have a rough lifetime around that long. Languages tend to be a bit longer because, the human of the sort of, I guess, the stickiness in the human mind, once you're sort of conditioned on a particular language, it sort of sticks around. And even though you might change the sort of framework that you use to program in, you might continue to program in the same language. Database platforms also tend to be fairly long-lived, I guess, because once a company's made an investment in a database platform, moving to a new one is a bit harder than, say, moving to a different application framework or a different language, and so they tend to be quite long in their life as well. And I guess the fundamentals of relational databases haven't changed that much either. So, database platforms, there's been the whole NoSQL movement, but within the relational world, the same, like DB2, SQL Server, Oracle, MySQL, I guess, and Postgres, those things have been around for quite a long time, some of them much longer than others, but still all of them fairly old. And so, that's sort of seems to be the cadence of those kind of things. Project management methodologies also seem kind of multi-decade. And this is sort of another just kind of rule of thumb that Leon and I put in. Anything that's sort of on the client side just seems to be feel a lot more churn than things on the back end, because I guess people are wanting to revision the look and feel of their front end. So maybe and front end, front end stuff just seems to be changing more because it's the stuff that customers touch and interact with. So we want to always be putting fresh things in front of them, and it just seems to be kind of these are not hard and fast rules. They're just kind of like general observations about how long things tend to be around. And client side stuff tends to rev a bit faster. We can also use quantitative measures to look at how popular various things are. So this is previously, on this previous slide, we mentioned database platforms being a multi-decade thing. And I guess the big change in that space that was talked about a lot was the NoSQL movement. But when we actually look, this is the Google search trends of SQL versus a bunch of NoSQL databases. We can see that the volume of search on all of those different things is tells a pretty clear picture, even though NoSQL is definitely kind of bumping along there and gaining in popularity a little bit. It's still SQL tends to dominate in a big way, and you can see there's database professionals obviously take a bit of a break over Christmas. I guess that's when all the backups are running or something, but yeah, you can see this very obvious sort of yearly trend going on there, and the volume of searching on SQL is much higher compared to all of these NoSQL databases. There's also a bunch of long-term industry trends, and I think people are generally aware of these, but it's probably just worth calling it out that you wouldn't want to be investing a lot of time in learning something that seemed to be going against the sort of total flow of the industry, like web development, open source, stuff like that seems to be the way things are going. And so anytime that you're investing in learning stuff, it's worth sort of thinking, how does this really align with the long-term industry trends that are going on? There's also something to be said for, and I think I kind of touched on this earlier, that sometimes the technologies that you invest in don't actually win, but you can still gain a great deal of knowledge, you can still gain some value from them by looking at the sort of larger trends and the larger sort of patterns and sort of the more general things. Like if we have a look at the pyramid, if we look at this pyramid here, even if our sort of specific technical skill doesn't actually pan out, I think we can still sort of look at the general patterns and things like that that technical thing that we were learning entailed, and we can still gain a lot by looking at we can still gain a lot of generic technical knowledge, even though the specific stuff might be kind of like wasted. And it's hard to tease out what's sort of implementation specific and what is general, but you would hope, for example, like if we were learning Unity development, that and Unity seems like an excellent example of something that's probably going to be around for a while because it's been around for a while already. But hypothetically, if Unity went away, you would hope that you would learn a fair bit about sort of 3D graphics and game programming and stuff like that, even though the actual, the specifics of Unity might be gone. You would still know a reasonable amount about games and stuff like that. So the example that that comes readily to my mind is with WPF. So I spent a lot of time investing in learning WPF, and things like WPF itself has sort of like reached an evolutionary dead end and is kind of a fairly minor player in the front end development sort of stuff now. But patterns like MVVM and stuff like that are still, and data binding and all that sort of stuff are still around, and so you can still gain some you can still learn some valuable lessons, even if the technology itself has sort of not really panned out the way you thought it would. Okay, another Alice in Wonderland quote. So Alice asks the Cheshire cat that was sitting in a tree, "What road should I take?" And the cat said, "Where do you want to go?" Alice said she doesn't know, and the cat says, "Well, it doesn't really matter then, does it?" So I think when we're thinking about skill acquisition, we should also think about what arc we are planning on taking or where we see ourselves in our career. And so if we see ourselves becoming, say, a manager, we should maybe put a higher weighting on skills down here in the non-technical skills part of the pyramid. If we see ourselves becoming maybe a solution architect or something like that, we should probably be investing more of our skills in this generic technical part of the pyramid. And then if we see ourselves as really doubling down on a particular technology and really becoming a master in that area, then we should be putting most of our effort up here into this specific technical skills part of the pyramid. So doing so does expose us to a bit of risk, as I said before, because this part of the pyramid is the most sort of subject to change. And so there's another strategy that you can use if you're going to go down that path called the barbell strategy, where you sort of focus on two things at once. You focus on the thing that's going to make you the sort of world champion. So you sort of really focus on the top part, on stuff in the top part of the pyramid, and then you focus at the very opposite end of the spectrum on the things that you are absolutely the worst at. So your biggest weaknesses, basically, say you're Linus Torvalds, the thing that you're best at is sort of your stewardship of the Linux kernel and C programming and stuff like that, and so you spend time investing in that. And the thing that you're weakest in is interpersonal communication, because you're a bit of an abrasive asshole, and so you spend a bit of time working on that end. And that's the sort of barbell. It's these two things on the opposite ends that are sort of balancing each other out. So in the financial investing world, there's this concept called averaging in, or dollar cost averaging, where you just sort of keep investing in things over time, and so you sort of smooth out any ups and downs in the price that you pay for things by just constantly investing. And so I think this is an excellent mindset to be having when you're investing in technical skills as well. For example, if you're only allowed to invest in one technical skill every decade, you would have to spend an inordinate amount of time, planning and thinking and deciding where the industry was going and agonizing. And then if you got it wrong, you'd be exposing yourself to massive risk and downside, because you may well screw it up. A better approach is just to invest a little bit of time all the time, and then you don't have to spend as much time planning and agonizing, and you can spend more time just learning. And then you don't have to worry about, well, if some of your bets didn't pan out, because you're using a sort of risk diversification approach. If some of your bets don't pan out, it doesn't really matter. So this is sort of a bit of a cheap throwaway line, but I really think every day on a project, every day when you're out working as a software developer, every day can be a professional development day. There's always opportunities to be learning. Even if you're on a project with sort of like dead end technologies, you can still be learning about practicing your communication skills or your attention management. You might be using a really crappy API that you never want to touch again, but you can learn things about what makes an API crappy. You can think to yourself, well, why do I really hate this technology so much? And then you can sort of have a more concrete view of what it is you hate about it, and that's a sort of valuable architectural design skill that you're building up by doing that. So I really think no matter what project you're on, what you're doing in IT, you can still be kind of learning valuable things every day. There's also a massive sort of leverage that you can get from working in groups with other people. So there's this sort of myth in any endeavor where people are inventing and creating things, that there's this the sort of like the lone genius who, against all the odds, sort of steals fire from the gods and delivers this miraculous thing. And that's largely a myth. That if you ever see any movies where they do that, it's probably an exaggeration, or it just looks good on paper or on screen. But in reality, it's always teams of people working together, collaborating, that achieve great things, and leveraging the knowledge of others, investing in helping other people so they can help you, and sort of doing that in a learning organization. That's the secret to being a 10x developer. It's not you being a singular person who's 10 times more productive than everyone else. It's a bunch of 10 people who are committed to that learning ethos and working together and collaborating together, achieving 100 times what they could each do individually. That makes each of them collectively, each of them together is a 10x developer, and so gives that 100 times productivity. And that's the whole basis of civilization, really. That's why humans, group together in cities and specialize in particular careers rather than just doing everything, and so that they can be more productive because they get to specialize in things and build up expertise and things like that. There are also, if we have a look at the pyramid from before, or bring that back into our minds, there are also some activities that really allow us to exercise every part of that stack at the same time. So helping other people is a great way of doing all those things at once. So you sort of, say someone asks you a question about a technology that you're aware of, but you don't actually know the exact answer to their question straight away. So you're going to be exercising your metacognitive skills, because you're going to be having to bring your attention to bear. You're going to have to be learning and sort of observing yourself learning and having a growth mindset. You're also going to be exercising your sort of sort of general non-technical skills, like your communication skills and things like that, understanding, where they're coming from, all that kind of thing. And then you're going to be actually exercising that sort of top part of the pyramid as well, your very specific technical skills, and maybe stuff in between as well, understanding the design patterns that the creators of this framework are using, or the design patterns and the stuff that the person who's asking you the question is going on about too. So you really get to exercise everything in that stack at once by helping people, and it's really a great way to build up your skill set. And it's a great, for a number of reasons. There's a great altruistic benefit to it, and it's also a very efficient, because not only are you solving, you're not just solving that person's particular problem, you're building up your own skills and hopefully translating some of those skills and understanding onto them too. So I think that's a really highly leveraged activity that people, that's very valuable. Some final thoughts. So basically, we've had a look, well, actually I should just go ahead and say it. All this talk about learning, if you think education is expensive, you could always just try ignorance. It seems to be working out pretty well for some people at the moment. There's also one fairly obvious sort of thing that we should be taking away from all of that, and this is to basically learn Vim. You saw before in Leon's like Cartesian coordinates of different technologies thing. Basically Vim, it's in the very top part of that magic quadrant for, no, I'm just kidding. You shouldn't learn, you can learn Vim, but that's not the specific takeaway that we want you to have. This is kind of a joke one as well. The specific takeaway that we want you to have is that you should treat knowledge like a financial investment. Invest your time in both low risk and high risk skills. Invest in a mix of metacognitive, non-technical, and technical skills. Use the Gartner hype cycle and technology adoption curves to understand where skills are in their life cycle, so you can figure out how risky they are. And you can measure it using Google Trends, Stack Overflow questions, things like that, that TIOBE index of language popularity. There's lots of hard metrics that you can use if you need to. You can use the Copernicus principle and industry timescales to understand the expected lifetime of technical skills, and so figure out once again how risky they are. You can invest in skills that will align with the career arc that you're on, and you can find learning opportunities in dying skills and uninspiring projects, and just help other people. And that way you can leverage, you can gain knowledge and improve your skills in the entire stack all at once. Thank you very much.